This single equation, delta x dot delta p greater than or equal to h bar over 2, reveals the universe has a built-in security system. Not bad technology, not clumsy scientists. Reality itself forbids perfect information. I'll show you why atoms would collapse without it, why your coffee table feels solid, and why you exist at all. Same object, same motion, perfect position, or perfect momentum, never both. Deep inside every atom, two properties compete for precision. Position asks, where am I? Momentum asks, where am I going? In your everyday world, they coexist peacefully. You know exactly where your phone sits on the table and exactly how fast you're scrolling TikTok. But shrink to quantum scales, and these properties become fundamentally incompatible. The more precisely you know position, the less precisely you can know momentum. Here's how this works. Quantum particles aren't tiny bullets. They're waves confined to specific regions. This free wave, single momentum, clear direction, blurry position. Now place boundaries around it. Watch what happens. The wave bounces, reflects, and interferes with itself. Position gets defined by the boundaries, but momentum splits into multiple components. Confinement didn't just contain the wave, it fundamentally changed its momentum structure. Every musician knows this fight. Pure tone, one frequency, equals definite momentum. Chop that tone instantly, summon harmonic army. 3x frequency, 5x, 7x, infinite family. Sharp timing demands frequency chaos. Every guitar riff you've ever loved fights this battle. Many physics classes teach this incomplete story. Measuring position disturbs momentum. Your photon bumps the electron. Your detector pushes the atom. Clumsy tools creating accidental disturbance. This feels satisfying. It implies we just need gentler measurement techniques. Better technology will eventually solve the problem. But that's not what's happening. Even if you never measure the particle at all, even if it's completely isolated in empty space, it still doesn't have a definite position and momentum simultaneously. The uncertainty isn't caused by measurement. The uncertainty is the particle. It's not about our knowledge, it's about what exists. Let me show you why. To manufacture a particle at one exact location, reality has to combine many different waves. Here's how. Each wave has a specific wavelength. Short wavelength means high momentum. Long wavelength means low momentum. To pin down position, these waves need to add up constructively in one spot and cancel elsewhere. That requires mixing many different wavelengths, which means mixing many different momenta. Want the position twice as precise? You need twice as many wave components, twice as many momenta in the mix. This is Fourier analysis, the same mathematical technique that compresses your Spotify songs and reconstructs MRI images. It's not quantum weirdness, it's unavoidable wave mathematics. Here's the fundamental geometry. Uncertainty volume cannot shrink below h bar over 2. Squash position, momentum inflates like a balloon. Squash momentum, position spreads outward. You choose which direction to compress, but the total volume stays constant. Think of it like squeezing a water balloon. The water has to go somewhere. Let's do a thought experiment. Imagine we could break the uncertainty principle. Electrons with perfect position and perfect momentum, clean orbits, clockwork predictability, classical physics perfection. Now try to pin one electron to one exact point, say, right at the nucleus. Perfect position, zero uncertainty in location. According to our uncertainty equation, that means infinite momentum uncertainty. Infinite uncertainty means the momentum could be anything, including arbitrarily large values. So this precisely located electron actually has insane kinetic energy, not sitting peacefully. essentially bouncing around at near light speed in random directions. The tighter you try to trap it, the more violently it moves. This isn't a measurement problem. This is the wave nature of matter, fighting confinement. The electron crashes into the nucleus. The atom doesn't just wobble, it collapses completely. One collapsed atom breaks its molecule. Broken molecules can't form cells. No cells means no life. No hydrogen bonds holding water together. No carbon chains forming proteins. No DNA preserving information. Basically, no stable chemistry anywhere. But h⁻/2 prevents this catastrophe. Position uncertainty means momentum uncertainty too. That momentum uncertainty creates outward pressure, a quantum repulsion that keeps electrons spread out. Electrons stay in their orbital clouds. Chemistry works. Biology works. You work.
Here's a direct consequence. Put simply, electrons can never sit completely still. Even at absolute zero, the coldest possible temperature, electrons still jitter in their orbitals. Why? If an electron stopped completely, we'd know its momentum exactly, 0. That would mean infinite position uncertainty. The electron would spread across the entire universe. But it's trapped in an atom. Position is already somewhat confined, so momentum must remain uncertain, must remain in motion. This minimum jittering creates what physicists call zero-point energy, the universe's mandatory minimum energy. Even empty space contains this quantum restlessness. Atoms stay inflated because their electrons can't stop fidgeting. Your kitchen table feels rock solid because 99.999% of it is empty space between atoms, yet electron clouds strongly repel each other, and uncertainty keeps those clouds inflated. When you touch anything, you're not actually touching atoms. You're feeling electromagnetic repulsion between electron clouds. Solidity isn't about dense packing. Solidity is about quantum pressure pushing back. Same principle powers the sun. Protons tunnel through energy barriers they classically couldn't cross. Position uncertainty lets them briefly exist where they shouldn't be. Fusion ignites. Many of the photons reaching your eyes ultimately exist because of quantum tunneling. So here's what we've established. Uncertainty isn't measurement error. It's built into wave mathematics. And it's not optional. It's what makes matter stable. Now let's go deeper. It's natural to imagine a hidden perfect reality. Sharp particles with definite positions, true velocities just obscured by measurement limitations. But quantum mechanics says this picture is wrong. There are no hidden particle positions waiting to be found, no secret trajectories obscured by our measurements, no real velocities behind the probability distributions. The blur isn't a measurement problem. The probability cloud is the particle. The wave function is the complete description. Uncertainty isn't our limitation, it's the nature of quantum reality. Think of uncertainty as a balloon you can squeeze but never shrink. You can choose to know position better, balloon gets narrow in position space, but it bulges out in momentum space. Choose to know momentum better, opposite happens. The balloon's volume, always the same minimum size. You choose the shape. Reality enforces the volume. Here's the deepest quantum truth. Particles don't have uncertain properties. Particles are made of uncertainty. There's no actual position hiding underneath, no real momentum waiting to be measured. Just probability distributions following mathematical rules. Yeah, reality is weirder than we thought. So is the uncertainty principle a limitation? In simple terms, it prevents perfect measurement. But it also prevents atomic collapse. No uncertainty minimum means electrons fall into nuclei, means no stable atoms, means no chemistry, means no biology, means no you. Here's an interesting pattern in physics history. Every improvement in measurement precision reveals uncertainty at a deeper level. We measure particles more precisely, find quantum uncertainty. We measure atomic clocks more precisely, find quantum timing fluctuations. We measure gravitational waves, physicists conceptually see quantum uncertainty in space-time itself. We're not eliminating uncertainty, we're discovering it is fundamental all the way down. So here's the key takeaway. Delta x times delta p greater than h bar over 2 isn't a measurement problem to solve. It's how matter is structured. The universe chose wave-based matter over point particles, chose quantum pressure over classical collapse. Every stable atom, every chemical bond, every biological process, all depend on it. Your existence isn't despite uncertainty, it's because of it. If this rewired how you see reality, welcome to decoding universe source code. Not memorizing formulas, understanding why reality wrote them. Hit subscribe. Next week, we crack why time flows in one direction.